So one of the things we did this chapter was graphing simple rational functions. There's two forms of these functions. The first one is in the form f of x is equal to a divided by x minus h plus k. The second form looked like this, ax plus b divided by cx plus d. Notice the major difference is this one has an x in the numerator and this one does not. In the first one, we find our vertical asymptote is x equals h. We can find that by taking x minus h and setting it equal to 0 because the denominator of a fraction is not cannot be 0, it's undefined. In the same respect, over here, because it's not as simple to just look at, we can say that cx plus d must equal 0, and you can solve for the x to find the vertical asymptote. The horizontal asymptote comes from y is equal to k. Since you are not going to be able to make this equal to 0, then, because a cannot be 0, then it cannot be k. So in the other form, we can take the coefficients and the ratio of a over c, and that is our horizontal asymptote. Y equals a divided by c. In the HK form, a tells us which quadrants it is in. A positive looks like this, and a negative is in the other ones. Negative is red, be in this one. And it doesn't touch your asymptotes, so it's a little bit harder to draw on this. So our first example, let's let it be f of x equals 3 over x plus 1 minus 4. So our vertical asymptote is x equals -1, and our horizontal asymptote is y equals -4. So our domain, the asymptote, means that these are the values that x cannot be. Is x such that x does not equal -1, and our range is y such that y does not equal -4. We'll look at what our graph looks like so far. And we have our asymptotes at x equals -1 and y equals -4. So because our a is positive, our 3 is positive, we're looking at it being in these two areas here. So I can make a table or I can use a shortcut, and I'm going to start with a table. And because the table can be used on all of the different types of equations. Now I'm going to choose my numbers because I know that x cannot equal -1, so I can choose two numbers smaller, -2, -3. And I can choose two numbers bigger, 0 and 1. So I'll plug in 0 and 1. So when I plug those in, I get 3 over 1 plus 1 minus 4, which is 3/2, minus 4, which is -2.5. So that point is 1, -2.5, about there. And then when I plug in 0, I get 3 over 0 plus 1 minus 4, which is 3 minus 4, which is -1. So 0, -1. And my branches get really close to the graph but don't actually touch them. And I'm going to have a similar, these branches are symmetrical. This graph is called a hyperbola. So it's going to look really similar on the other side, like a reflection. So let's plug that in, 3 over -3 plus 1 minus 4, which is 3 over -2 minus 4, which would be negative 5.5. And when I plug in 2, 3 over negative 2 plus 1, which is negative 3 minus 4, which is negative 7. So let's see, where are those points? At 2, it is negative 5, or negative 2, it's negative 7. And then at negative 3, it was negative 5.5, or 5.5. Oh, I think I counted wrong on that. Let's erase this one. No, it's not wanting to erase that for me. Oh, let's not do that. Okay, this point is a little bit higher, but it's not going to cooperate with me and let me erase it. So our branch is over here. The point's more like 4, 5, 6, 7 right here, not this one. So we're deleting that point there. And we can see our branches are pretty symmetrical, kind of in this line y equals negative x. If we look at that, I think it's like a reflection in that line. And that's our graph. So we make sure that we plug in two numbers greater than our vertical asymptote and two numbers less than our vertical asymptote to get our graph. So our next equation is the ax plus b and cx plus d form. So to find my vertical asymptote, I take x minus 2, set it equal to 0. So x is positive 2. And my horizontal asymptote comes from the coefficients. Remember, there's a 1 in front of the x. So it's y equals 3. So my domain, x, does not equal 2. And y such that y does not equal 3 is my range. So I draw my asymptotes on here, positive 2, positive 3, those in blue, and in this one we definitely have to plug in some points to find out which way it's going to go. So we're going to plug in these numbers here, 1, 0, 3, and 4. So we make our table, and we get, let's see, 0, 1, 3, and 4. When I plug in 0, I get 0 plus 1 over 0 minus 2, which is negative 1/2. When I plug in 1, I get 3 times 1 plus 1 over 1 minus 2, which is 4 over negative 1, negative 4. So those 2 points, 0, negative 1/2, 0, negative 1/2, and 1, negative 4. And I draw my branches. And I have, I'm going to plug in 3. Remember, I also have the symmetry, and I can use that, or I can just plug it in. 3 times 3 plus 1 over 3 minus 2, which is 10. I don't know if my graph's going to go up that far. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 3, 10. Let's put that in red as well. And then when I plug in 4, 3 times 4 plus 1 over 4 minus 2 gives me 13 halves, which is 6.5. So 4, 3, 4, 5, 6.5. Right there. And then we draw branches. I'm running out of space there. But so that's in a nutshell how you can graph those equations. And we talked about a few others. If we don't like that form, f of x equals 3x plus 1 over x minus 2, we can actually divide to put it into the ax plus x minus h plus k form. So I can do that by taking x minus 2 goes into 3x plus 1. X goes into 3x 3 times. 3 times x minus 2, remember we multiply both, 3x minus 6, and we subtract, so that becomes plus, and we get 7. And that's our remainder. So that becomes 7 over x minus 2. And when we write the plus next to it, so we can rewrite that as 7 over x minus 2 plus 3. And there it is in HK form. And then I'll show you the shortcut in HK form. If my asymptote's at positive 2 and positive 3, I can go from the intersection of my asymptotes, I can use the 7, and I can go up 7 into the right one, and to the right 7 and up 1. Because it's positive, it'll be in these two quadrants. So if I go over 7 and up 1 from my asymptote, and I go up 7 and over 1 from my asymptote, I get my branch here. And if I go down 7 and over 1 from my asymptote, and over 7, 2, 3, 4, 5, 6, 7, and down 1 on my other branch. And that's the shortcut using the 7. If it's negative, I would put it in these two quadrants.